All right, problem 8. We're given the function g of x. Find two values of x of which the tangent to the graph of g is horizontal. So what we want to do is we want to know when is the slope equal to 0, because horizontal has a slope that's equal to 0. So in order to find a tangent that has a slope of 0, we need to take the derivative. So we want the derivative of g of x, which gives me 3x squared minus 6x minus 9 is my derivative. Now I'm going to set that equal to 0, so we can find where the slope is equal to 0, because this is the slope function, the gradient function. I noticed that this can all be factored out at 3, and then I can factorize that some more. X times x, to get 3 I need a 3 and a 1. I need more negatives than positives, so it's going to be minus 3 and plus 1. So now I'm going to set each of those equal to 0 and use my zero product property. Using my zero product property, I set those equal to 0, and so I get my answers that x at 3, the two values is when x is 3 and x is negative 1. That would be where the tangent would be horizontal or have a slope of 0. Okay, so for each of these values, determine whether it is a maximum or a minimum. Okay, so if I look at my function here, I can actually say, okay, at negative 1 and at 3, I'm going to have, the slope is going to be 0. And if I were to graph this parabola, it would be a happy parabola. So I could actually graph a little sketch of this parabola. These are going to be its x-intercepts, and it's going to be happy. It's going to be concave up because the coefficient of x squared is positive. And so therefore, at this point right here, I have a positive slope going into a negative slope. So at 1, I have a positive slope going into a negative slope. So that's when x is equal to negative 1. Positive slope going into a negative. So at x equals negative 1, we're going to have a maximum. And for the other one, at 3, I have a negative slope. This is negative down here and positive up here. Negative going into a positive. So that means at x equals 3, I'm going to have a minimum. Okay, there's other ways I could have done that. I also could have taken the second derivative and looked at concavity, concave up and versus concave down. So a bunch of ways I could have done that. In fact, when I look at here's my answer key that I actually made first. I actually found the second derivative, and I plugged in at 3. I get a positive value, so therefore it's concave up at x equals 3, which means that at x equals 3 I have a minimum. And then, again, I took the second derivative and I evaluated it when x equals negative 1. I got a negative answer, so that means that it's concave down, so therefore it's a maximum. So I did it two different ways. The first time I did it by using the second derivative to determine concavity, but just now I wasn't really looking at my answer key, and instead I just looked at my sign diagram. So a couple different ways you could have figured that out.